All right, so let's just keep working with these theorems we learned in that one video. So we have kind of a complicated picture. So let's just break down what's going on. We have chord AC, chord FD. We have a couple radii. From P to B is a radius, from P to E is a radius. We do have a distance from the center to the chord, so PG is a distance to the center, perpendicular. PH is the distance from the center to the chord. That distance is always perpendicular. Okay, great. So we broke down kind of what we're looking at. Now let's fill in some information. Because PB is perpendicular to our chord, if your chord is perpendicular to, the theorem said diameter, I could extend that to a whole diameter, then your chord is bisected. So we know that this is congruent. So GC is congruent to GA. So if that is 2 units, we can go ahead and fill in this is 2 units over here. We have another PE as a radius, but if we extend it, there's a diameter perpendicular to a chord, so it does bisect the chord. So we know these are congruent to each other. We don't know what they are right now, but I'm guessing we will get that information. We know that PB, the radius, will be congruent to PE, the radius. We'll see if we need that. And then they gave us some information. They said the measure of arc AB is 43. So if we find AB, that's this arc right here, is 43 degrees. And then they said that AC is congruent to DF. So chord AC is congruent to chord DF. Okay, so that tells me right now, if AC was bisected and it's congruent to DF, which is also bisected, then all those smaller segments will be the same. So I'm going to go in and erase just one of these marks. Oops, just kidding. I'm going to erase all of those marks. And I know that I'm just going to mark the congruency marks that we did for GC and GA. And because those are each 2 units long, I know that these are 2 units long. When you have congruent chords, you have congruent arcs. So I know that arc AC will be congruent to arc FE. Because this chord got bisected, this arc will also be bisected with that BP. So we're going to label arc BC 43 degrees. And then we can do the same thing over here. FE is a 43 degree arc and ED is a 43 degree arc. All right. Well, we filled in some information. Let's see if that is enough to answer our questions over here, and maybe we'll have to do a little more math to answer some more. So find AC. So that is going to be segment AC. From A to C, we can see it's 2 units and another 2 units. So AC is 4 units long. Find DF. Well, up here we said AC was equal to DF. Also, if we look at DF, we can see it's 2 units, 2 units. So DF is 4. Find the measure of arc AC. So from A to C is that 43 doubled. So if we just double the 43, we're going to get an 86 degree arc. Let's see, find FH. So from F to H, we already talked about why that is 2 units. So FH is 2. Next is find the measure of arc DE. So from D to E, 43 degrees. Again, we talked through all of this, and now we're just we've already talked about how these numbers are what they are. Find the measure of arc DF. So from D to F is a 43 doubled, so 2 times that 43 gets us 86 degrees. All right, and then a bonus question, of course, find the radius of the circle and segment PG. So if we look at our circle, the radius, they have a couple drawn in for us from P to E or from P to B. Sometimes it's easier just to draw in your own radius. if you don't like the ones that they drew in for you. So I'm going to focus on this right triangle right here. So I'm going to draw in radius PC. Let's see, I'll draw it in with green. And then I'm going to redraw that right triangle down here. Oops. Where P right here is the center of our circle. This is C, and then this right here is G. We know that this is 2 units long. If we look at the picture real quick, we have the center of our circle. If you follow each radius out, it's creating that 43-degree intercepted arc, which means the central angle will have the same measure. Remember, a central angle and its intercepted arc have the same measure. So we have a 43-degree angle right in here at P. All right, so find the radius. The radius of the circle is this side right here, PC. Well, we don't have 3 sides of a right triangle to use Pythagorean theorem. We do have an angle though, so we can use trigonometry. Remember how much we liked that right triangle trigonometry? I guess let's make sure we know there's a right angle right there. So we're going to go off of angle P. We know the opposite side, and we're trying to find the hypotenuse. So sine, cosine, or tangent, it's the sine function that uses opposite and hypotenuse. So let's just, here's our work to find the radius. The sine of angle 43 is equal to the opposite side 2 over the hypotenuse x. We can put this over 1 and just cross multiply out of these fractions. Sine of 43 times x is x times sine of 43. We set that equal to the other cross product, 1 times 2. And then to solve for x, we just divide by sine of 43. So x, which is our radius, is 2.93. So we will just conclude that the radius is equal to 2.93 units, and that is a rounded answer. All right, the other thing we were asked to find is segment PG. So I guess that's probably why I use this triangle, because I could find this radius and segment PG is in the same triangle. So to find segment PG, I'll go ahead and label that with a Y, not to confuse it with the X we just used. And we can use trigonometry again. This time we'll use the opposite side 2, and we're trying to find the adjacent side, which is our tangent function. So we can say tangent of 43 is equal to the opposite side 2 over the adjacent side y. Let's put that tangent of 43 over 1 because we're about to cross multiply. Tangent of 43 times y is y times the tangent of 43. Set that equal to the other cross product of 2. Let's divide by tangent of 43 to get the y alone. And then we just grab our calculators. 2 divided by tangent of 43 is 2.14, and that y was representing segment PG. So we know that PG is equal to 2.14 units.